Then I start the ignition. After that, of course, we will be we should see the CAN communication happening on the CAN bus. So similarly, if you see if you have seen the Kano trace or any other communication analysis tool, similar kind of a replica we have tried to implement here, wherein you will be able to see the messages coming from DUT and the simulated node on this particular CAN master trace, and you see the real-time observation here, like the messages coming from infotainment ECU, BCM controller, and other subsystems inside this particular hill setup that we have prepared. Whenever we will be changing the temperature sensor values manually from here. So for now, like since the temperature has been increased to more than 30 degrees Celsius, like the AC motor is turned on via the infotainment controller, and it is trying to decrease the temperature to 30 degrees Celsius, and then the AC will be turned off. So this basic level of feature that we have incorporated in this particular bench setup. So during this operation, if any fault has been created, for example, sensor fault shorted to ground, so the operation which was happening in the background to make the cabin temperature cool, it will stop because the fault has been created, and respective DTC should be logged in a fault memory of controller. So if you want to do the signal level analysis, in most of the cases on the hill bench, we have to observe the value at digital level, or so we have also tried to replicate the oscilloscope window. So it is again a replica of control desk, wherein you need to observe sometimes the values of some signals manually or graphically. For example, switch button has been pressed or not. So those kind of signals, if you want to try, you can just tap in here and observe it here. Similarly, if I take you to the simulated controller tab, so like it is a headlamp switch, we are just turning it on, headlamp, left turn indicator, right turn indicator. So BCM is the input controller, wherein we have incorporated these buttons, and for the output, if you see the output is being turned on, which has a delay of 1 second to flash the left turn indicator and right turn indicator. And same is the case for headlamp, wherein you have a provision to change high beam, low beam. If I remove the particular fault condition here, the algorithm will start again in the background from the controller, and it will try to achieve reduce the temperature to 30 degrees Celsius, and the blower will turn off. So um, whatever real-time projects we are working on across the industries, we have tried to implement in this particular hill system that we have prepared. So whenever a person will go on a control desk or experiment environment bench, he or she will be facing these kind of panels or parameters that based on the test case, he or she has to change the engine RPM value, change the temperature sensor value, then observe the output. So these kind of statements we are targeting uh, or we are studying here on this hill bench. Similarly, we have prepared the UDS console. So if you have seen Kano window, like Kano diagnostic console, similar kind of a console we have tried to prepare here. So if you put some diagnostic command here and send the request to ECU, then the controller should respond. For example, I'll just create a simple fault and again send this request. So the respective fault with the DTC value should come here. So if you see like the respective DTC, 3 byte DTC and status mask, we have for now it is like F up we have set it, but that's what like the controller will say, acknowledge the uh, request from tester and respond to it. So this is what like the control desk that usually a hill tester will see or will have to face. Now comes the important part of this hill bench. So in the background, we have the configuration desk, which plays a major role to create these all panels, to create these all panels. So it involves a lot of understanding, lot of parameter creation, model creation, and mapping. So that's where our next panel comes, like Simulink. Why we will need a Simulink plant model or MATLAB Simulink environment? So basically the health system involves, it provides a real-time output to you. We have various controllers connected to health system. Sometimes the controller are simulated also. But what about the input and output part? So as you know, like we have seen many sensors here, right? Cabin temperature sensor, then pressure, various pressure sensor as well. So how these sensors are being part of health system? So to answer that, we have this hill Simulink plant model as well, wherein we have simulated the sensors component. For example, if I take example of ambient temperature sensor, if I change some value here like minus 10 degree Celsius to some, so it should give a value in terms of some resistance or voltage, because controller at the pin level, you will be either sending the resistance or voltage. Of course, in the software logic, that particular electrical signal value will be changed to either in the 1 or 0 form. But at the hardware level, to controller pin, to sense the temperature or to sense the pressure, respective voltage or respective temperature has been sent. So that mitigation, that this particular problem mitigation is being taken care in this in the hill system. So in the MATLAB Simulink environment, we'll be converting the real-time temperature or pressure entities into the resistance or voltage value, and whatever values that we have gathered or got from the Simulink, will be feeding it to Hill IO cards. So in the Hill system, this is particular major unit that we will be studying during our training session. We have different IO cards. To study these IO cards families, I have taken a DSpace based card library, so that you can see it here like DS6101. These are the different cards used on the DSpace Hill systems. So this kind of a channel mapping, you will be able to do it during our training program. So how exactly the the values that we have gathered in Simulink environment, how can we map it to controller via Hill IO card? So with that understanding, we have prepared this panel. So a user who will be using this particular bench, he or she will be able to easily understand the role of these IO cards, whether it is register card. Like you can see, this is a digital D0 means digital card. Then we have IS. IS is like current sensing card. So for just to give an example, uh, we have this particular temperature increase, and you see current value has been changed here to 1.2 amp. If I just make the temperature 0, sorry, below 30 degrees Celsius, we see the particular value at current is 0. But if I change the temperature value to high, the current is being consumed by the DC motor. So this is what the beauty of Hill system. Hill system will give you real time verification that the load connected to ECU is actually performing its operation, because the current has been dropped or consumed by the system. So that level of verification is being expected from the hill system tester when we are performing the hill testing. So that's what the IO cards plays a major role here, because controller doesn't have the capability to measure the current consumed at the load level. And also controller cannot provide you that amount of current, because controller can only provide comment or a command to turn on or to turn off the load based on the software logic implemented in it. But what exactly the current or what is the resistance consumed across the load, that's where the Hill IO card plays a major role or vital role here. And we have to map a respective current sensing channel across the load, which is connected to to the controller. So for example, for the demo purpose, we have connected this right indicator, left indicator, headlamp, the blower motor, as a output of our infotainment controller. Of course, in other industries, these outputs are maybe mapped to BCM controller or some other controller. But just to give a understanding, this is what uh, a generic uh, controller's input and output looks like, and this is how like it is being implemented and testing on the hill system. Then we have a generic panel created here. We have a breakout box. So wherein a person, suppose in the release level, let's say some changes has been happening. The engine coolant temperature input has been changed from analog input pin 3 to analog digital input 4, something like that. So of course, with this particular breakout box panel, we can manually change the particular variation. Then we have this fault insertion unit. So in hill system, we have a provision to create multiple various fault like shorted to battery, shorted to ground. In case of sensor or input fault, we have out of range, high, out of range, low kind of fault. So that level of understanding how the fault has been created, we will be discussing during this panel discussion phase. And the last tab that we have prepared to give you understanding how exactly the signal flow happens in the hill system in background, like the signals coming from right from the plant environment or outer environment, then it is fed to the digital or analog card in the hill system. Then in parallel, it routes via the fault insertion unit channel, and then to the then the controller's input pin, and it is broadcasted on the CAN or most or Ethernet bus, depend on the network that we have. And at the output side, the load which is connected to either at the high side drivers or a low side driver, how exactly it is being the current or its status is being measured or tapped at the hill environment using this IO card, and then the expected output has been shown on the control desk window or at output window. This is how we have tried to incorporate the understanding. Definitely, this flow is a generic flow across all the system that we see, but the terminologies like fault insertion unit, various kind of IO card family from the D space, controllers input output, then deciding the temperature and its analogous resistance value. This all thing will be discussing and learning in detail during the training. Uh, I would just like to give you a brief on Simulink model, like how we will be preparing the uh, input plant models during using the Simulink based platform. So we'll be having hands-on practice how the input and output subsystem is being implemented using the Simulink platform, and of course, a couple of MBD portion of MBD we will have support here. Like with the help of Simulink only, we'll get understanding of MBD related topic. So far, anybody has any concern, any question?
So you will be explaining like how to create a scenarios, how to simulate for example, if you take ADAS or anything else, how to create a scenario, all these things you will be explaining about it.
Yes. For specifically for ADAS topic, yes, that is also will be there. Now, for now, like we do not have prepared that tool at the moment, but of course, down the line we will be adding uh, different tabs here, or we will be creating a different tool wherein we will be able to create the scenarios. For example, front collision warning or the features like adaptive emergency braking or emergency steering assist. So those scenarios we will be able to prepare, and based while creating the scenarios, we'll understand what are the parameters required. Like for example, if you see how exactly the time to collision has been calculated, so which particular point we should consider to calculate the TTC. So those kind of concept we'll be discussing while creating the scenarios. And of course, at a testing side, when we will be testing that scenario on the testing tool, we'll be capturing the KPI related parameters also, like what is KPI when it comes to AEB, when it comes to ACC feature, and with that level of understanding, we'll be performing the testing. So if you add that particular project like ADAS testing as a part of your CV or resume, you should be able to answer the questions like what is KPI, what are the KPI parameters for AEB, what are the KPI parameters for ACC. So we'll be discussing those topics. We'll be gather the understanding of those topic while creating the scenario and testing the ADAS features. So just to give a confidence, like this is like manual hill system. This is like generic hill system that we have prepared for traditional features we have across every vehicle. Now comes for advanced topic like EV or ADAS, we'll be preparing a different tool, and that will fulfill the purpose of ADAS testing.
Like same like virtual one or like anything related to space or anything?
Yes, it will be virtual, unfortunately, because as you know, like means we are in discussion with IPG also in the background. If we get some trial version from them with IPG and with AVL, if things goes well, we will have a probability to get their hands-on experience on car maker or AVL based simulator. But at this moment, I will not be able to promise you that on that part, but for sure we'll be preparing the similar kind of a tool setup wherein in the virtual environment we will be creating the scenarios and testing it.
So T space, like you'll be explaining only the architecture or what exactly?
Yeah,
Or say
so just
the
to give you
requirements you get only B space mostly.
okay, so just to give you a brief of on a glimpse of the space side. So what level of discussions we will be having during our training session. So as a part of content, if I can show you, so whatever tools or like subsystem part the DSpace system actually has, definitely that all topic we'll be discussing as a part of our hill training program. Whenever we will start with the hill model, we'll be covering these different topic. So even though we do not have the disk space system available at with us, but like disk space Calexio, what is micro lab box, what is lab box, the different automotive simlink libraries are there, what is target link. With these concepts, we'll be giving you a thorough understanding. And then definitely DSpace has a huge libraries like of IO cards and all. So if I can just walk you through this particular slide, you will be getting a in detail understanding of each and every card that DSpace Hill system involves. But just to give you a hands-on, we do not have actual system available. But with this understanding, if you try to uh, consider these parameters, understand if you understand these all parameters, you will be easily able to make a practice on this particular bench. You can be able to map the respective channels from the IO card library, and that's what these activities are being taken care by the hill infrastructure engineer, if I just say, because hill tester usually don't have access to configuration desk in most of the cases. They're only responsible to test the features using the control desk, and whatever activities that is being carried out as a part of Simulink team or hill infrastructure team. So we'll be covering both the activities, infrastructure as well as the testing activities.
Are you guys explaining about the hardware level setup of a hill setup and all, or how it is?
Yes. So just like we discussed, right? Uh, this couple of slides, right? So definitely we will be having a discussion at a hardware level. So like for example, how exactly the hill system looks like. So we'll be having a thorough understanding of each IO component in the system. Like you will be getting understanding of FIU, fault insertion unit. What is actually resides in the fault insertion unit is different channels, like these digital IO channels. How many channels are there, and how to map those channel to controllers input output. Um, for example, if I may just ask you the question on a temperature side, like we see this temperature, right? So if I change the value of 22 degrees Celsius, you see that the respective resistance value is being changed here. So what is the logic behind this? This level of understanding will be so definitely it has some base, right? So uh, behind choosing this ambient temperature, so there will be some electrical characteristic that we will be studying, and this ratio like temperature in degree to resistance in ohm, this ratio we have tried to replicate it in the MATLAB Simulink environment. So from where if I take you to the subsystem part here, like we have prepared 1D lookup table to convert the value from degree Celsius to resistance. But to implement this logic from where we are getting this input, so we have to go through the electrical characteristic of that particular temperature sensor's part number. So uh, every component in the vehicle, it has part number including your ECU temperature sensor. So based that with that background we have prepared this all subsystem and try to incorporate in the in this particular hill bench. So definitely during our training session, we will be getting understanding of all these background of electrical characteristic of each input sensor as well as the load part. Like if, for example, if I may show you this, yeah, we'll just turn on the hill system bench again. So if I just turn it on, you see that current has been the current rating is being changed here, like 0 ampere and third 300 milliampere like that. So this is like rated current against the left indicator load. So uh, it's not like every time we should give some random value here. So based on the part chosen part number, this component is being simulated in the hill environment. Right now it is a form of resistive load, but if I see when I turn on this AC blower, this is not resistive, it is a inductive load. So the output part which is connected to your controller or device under test, which load should be resistive, which load should be inductive, based on this kind of understanding we will be getting throughout the training session. I know it is like mostly right now for the people who are very new to this environment, it is they will not relate it, but with some background or some understanding, if you see an infrastructure engineer definitely face these kind of questions. Like let's say I have some fan as output of a controller, how should I simulate that fan into hill system without purchasing that actual fan? Or in off-road vehicle we have various hydraulic models, right? We have a lifter, we have some folder or something big like just take example of excavators. So those all huge component we do not have liberty to incorporate or connect it to hill system. So how we can replicate those actual mechanical or electromechanical part into hill system? So that's where the inductive and resistive load plays comes in picture, and we try we place those load in the load box in the hill system rack, and then we map the different channels like current sensing channel, resistive channels, to gather the amount of current consumed by the load when the operation is in progress. So these were like with that detail level we will be studying throughout the training session whenever we will be starting the model of hill infrastructure or hill testing as a part of our training syllabus.
So what project exactly you will be explaining?
So just to give you the overview, I'll just stop sharing again. So in the beginning presentation, I discussed about the training program. So this is like a generic syllabus that we have prepared. So as a part of fundamental or principle of ECU testing part, we have tried to cover the understanding based on the ISTQB principles, like what is white box, black box, and different test design techniques. And we will be also providing you the assignments. So based on the training model that we have covered, so based on that, we have prepared some assessment sessions also to check the particular participants' level of understanding. So if I walk you through the different training models, wherein you will be getting understanding of model in loop, software in loop, hardware in the loop. Uh, as I discussed on the bench, the tool that we prepared, we will be doing the practical uh, assignment. Like we will be providing the test cases, and those test cases you will be able to execute on the Hill system, and we will be reviewing your test reports, how exactly the testing has been performed. As a part of test automation or like framework creation, we will be discussing here the Python and Capel scripting, and based on the problem statement, a, a particular attendee will be executing the testing script on the tools that we will be preparing. You'll be getting understanding of CI/CD, continuous integration and continuous deliverable, either on the Jenkins or Docker-based platform. So individual person will be able to create the node and create the pipeline and make their own system as a end-to-end testing infrastructure. So this is how like we have prepared the in detailed syllabus for this training module.
So have so like what are debugging like exactly? How do you debug?
Yes. So for debugging part, definitely we will be discussing on the real-time problem statements. For example, let's say we have some switch, like example in terms of left turn indicators. Couple of time it happens like we have a concept of active high and active low switch. So even if the user is providing command or pressing the left turn indicator, the indicator is not turning on. And in the seal environment it is quite easy, like the software will look fine, but these kind of issues when will be captured easily on the Hill system. So there is a concept called active high and active low switch. If the left turn indicator switch input switch is being mapped as active low switch, and if you are providing command as turn on, like we are sending logic 1 to turn it on and logic 0 to turn it off, which is actually reverse of active low principle. So this will be this kind of use cases we'll be discussing as a part of debugging sessions.
Coming to infotainment, so what exactly will be which module you will be explaining?
Sorry Kaushik, I did not get you.
So I saw in your curriculum like infotainment
Yeah,
testing.
yes. So infotainment is like I mean like it is generic or easy to relocate as a just to get an understanding. For example, audio input. Then we discussed about AC blower. So that is the reason like I have taken infotainment as a use case. But of course, if you want to take another controller, for example, powertrain or any other controller as a part of subsystem, we can definitely have a scope to incorporate it in our Hill system. And of course, like in future, we know like we will be able to put the DBC file from from the old project that we have prepared. We are trying that also. Like the Hill system that we have just seen, you will be able to import a DBC file in it, and those messages we can see on the real time. Then comes the ECU test tool, which is a renowned tool across the automotive industry, specifically for the test automation. We have a training material available for this ECU test tool, but we will not have the actual tool available to make the hands-on. But we'll be during our training session, we'll be discussing each and every concept of uh, the ECU test tool terminologies, like what is TBC, what is TC, um, TCF, like test bench configuration, test configuration setup. So all these concepts we will be discussing during our training session. And similarly, like we'll be preparing the tool which is in parallel to test automation uh, tool, like ECU test tool, and we will try to replicate those level of understanding, whatever actions has been happened in the ECU test tool. That will be our next line of action. But from the theory side, I would say definitely we will be making sure you that, like, how exactly automation desk looks like, what are the activities or practices has been happening in automation desk and ECU test tool. That kind of knowledge sharing will be having in this particular training module. So I think I'm done from my side. Do you have any questions, any concerns from the team?
I saw like fishbowl and something else. So you will be explaining that. Or-
Of course, we will have a scope of it. Means, as I discussed, like definitely we have the window of adding and removing some portion of the training module based on the need necessity. Okay, I think then I think we will stop it here for today. If you have any concerns, any